Hello guys, welcome back to my YouTube channel. So today we are going to solve day 26 problem of this month on Leetcode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 494, target sum. Okay, so in this problem you are given an integer array nums and an integer target. You want to build an expression out of nums by adding one of the symbols plus and minus before each integer in nums and then concatenate all the integers. Okay, so for example, if nums is equal to 2 1, okay, so you can add a plus before 2 and a minus before 1 and concatenate them to build the expression plus 2 minus 1. Okay, we have to return the number of the different expressions that you can build which evaluates to the target. Okay, so now here let's take this same example only. Okay, so let's say this is my nums array 2 and 1. Okay, so here let's say my target is going to be 1. Okay, so now how our recursion basically works. So in a recursion we have two options now, whether we want to take this 2 as positive 2 or negative 2. Okay, so initially let's create one variable sum. Okay, and initially take this sum as 0. Okay, so now here I am at this particular position. Okay, so here I have two options now, whether I want to take it as positive or negative. Okay, so if I take it as positive, so and add it to sum, so my sum is going to become plus 2. Okay, or if I take it as negative, okay, and add it to sum, so my sum is going to become minus 2, right? 0 minus 2. Okay, then here for plus 2 I have again two options. Okay, my I is going to move forward, all right, I is moving to this position, and here I have two options, right? So if I take this 1 as positive, okay, or if I take this 1 as negative, okay, and here also I have two options, if I take this plus 1 as positive or this 1 as negative minus 1. Okay, so here if I evaluate this expression plus 2 plus 1, okay, I will get 3. If I evaluate this expression plus 2 minus 1, so I will get 1. Minus 2 plus 1, I will get minus 1. Minus 2 minus 1, I will get minus 3. Okay, so here this is our target. Okay, and we get this target, okay, at this position, okay, only one time. Okay, so I have solved this using multiple expressions. Okay, whatever is possible. Okay, sometimes I use plus 2, sometimes I use minus 1. Okay, so these are all the different combinations, right? So in all these combinations, only in this combination I'm getting what? I'm getting 1, okay, which is equal to target. So output for this one is going to be 1. Okay, this is a simple code of recursion. Okay, and when our this constant size is very small, okay, then it is possible to pass it, okay, without any issue. But if the constant size is large, then we have to implement the memoization as well. Okay, so first write the basic code. Okay, then after this I'm going to explain this example, okay, with recursion. I'm going to create one tree as well for this one. Okay, and that is going to be of 20 minutes video. Okay, in next 20 minutes I'm going to completely draw this recursion tree, okay, with memoization. Okay, I'm going to explain this in very much detail. Okay, but first let's write the simple code without memoization. Okay, so let's see. So here what you need to do, so we have to calculate the total number of ways in which we get our target. Okay, so here let's create one variable int total ways, okay, and set to 0. All right, and here I'm going to call this method calculate base. Okay, and in this I'm just going to pass nums. Okay, and I'm going to pass the index. Okay, right now I'm at 0 index, and right now what is value of my sum? 0. Okay, in the starting, and the target that I want to obtain. All right, and here after this we have to just return the total ways. Okay, now let's write this method private void calculate ways. Okay, this one void calculate ways. Okay, so in this I'm just going to pass nums, I'm going to pass index, I'm going to pass sum, okay, and I'm going to pass target. Okay, and here one base condition. So if my index is equal to nums dot length, all right, then inside this I'm just going to check if my sum is equal to target. Okay, so here in that case simply increment the part of total base plus plus. Okay, simple. And here in the else part, okay, in the else part, okay, so we have two different options, right, whether to take +2 or -2. Okay, so here what I'm going to do, I'm going to call this calculate ways method. Calculate ways method. Okay, so in this what I'm passing nums. Okay, now I'm moving to the next index, so index +1. Okay, so if I take this as positive, so in sum I'm just going to add this now, sum plus nums of index. Okay, this is going to be my next sum, and here I'm just going to pass target. Okay, now we have two options, right? If I take this as positive, okay, and if I take it as negative. Okay, so here instead of this plus I have to add minus, right? And that's it. Okay, now let's run the code and see if there are any code issues. All the test cases has been accepted. Now let's submit it. Okay, so see, our solution is accepted, right? Easy. Solution is accepted and we are somewhere here, right? Now let's try to implement the memoization as well. Okay, so I want to move from this to this, okay, somewhere here. Okay, and for this question length is very small. Okay, so that is why we are able to pass all the test cases. Okay, but let's implement the memoization. Okay, so now let's understand this example. Okay, why we need the memoization here. Okay, so here if you see carefully, we have this target, right? Target is to 3. Okay, so here if I use this as +1, +1, +1 and -1, what is the total sum we are getting here at index 4? Okay, 0 1 2 3. Okay, until in index 3, what is the total sum I'm getting total sum is 3. Okay, and if I use here like this +1 -1 +1 +1, so here also at this particular index 3, okay, here also we are getting total sum as 3. Okay, and here +1 -1 +1 +1. Okay, until here also I'm getting this total sum as 3. Okay, until here. So in my recursion code, sometimes I'm going to use this as -1, sometimes I'm going to use this as -1, sometimes I'm going to use this as -1. And whenever I was at index this 3, okay, until here, I was seeing that I'm getting the same sum. Okay, then after that I have to just solve this one now. So here if at this particular part I have solved this +1 and -1, then why do I need to solve it again and again? +1 and -1 here, +1 and -1 here. Okay, it doesn't make any sense. If I calculated it here only, then simply call the result. Okay, simply we know the result that until here when my sum was 3. Okay, so we know the result for the next part. Okay, remaining part. Until here if my sum was 3, we know the result for the remaining part. Until here if my sum was 3, we know the result of remaining part, which we have calculated here, right? So that is a use of memoization here. Okay, so now in my memoization array, okay, that I'm going to create, it's going to be 2D array. Okay, so here what are the different type of sums which are possible? Okay, so if I do the complete summation of all these, so I will get 5. Okay, 1 plus 1 plus 1 plus 5. And if I use minus minus minus, okay, so I will get -5. Okay, but in my array, okay, in my indexes I can't store the values at negative indexes. Okay, it is not possible, so I have to make this as positive. Okay, so in this if I add the total sum, which is 5 here, okay, so I will get 0 here, and here I will get 10. Okay, -5 plus 5 0, 5 plus 5 10. Okay, so now this is going to be the size of my memoization array. Okay, so 10, max size is going to be 10. Okay, so this is what we need to do. Okay, so from 0 to 10, 0 to 10. Okay, 0 1 2 to 10. Okay, but all the results are possible. Okay, so now let's understand the recursion tree, okay, for this particular example. So let's see how recursion is going to work here. Okay, so initially this is my complete array, right, and my I is at this particular index, right? So we have two options, right? We can use plus, okay, in front of this one, or minus, right? So here we have two options now, so let me do like this, okay. And here I'm just going to add the two options that I have, okay. So this here and this here, okay. So now in both the cases my eye is going to move to the next position, okay. My eye reaches to this index, okay. And here also my eye is going to reach to this index, okay. And here if I do use this plus symbol, so here my sum is going to become 1, right? And here if I use a minus symbol, okay, so initially let's say my sum is 0, okay. So in 0 if I'm adding 1, so I'm getting sum as 1. In 0 if I am subtracting 1, so I will get sum as minus 1, okay. And you guys know that our target is nothing but 3 here in this example, right? Target is 3. And what is total sum of this one? So total sum of this complete one is 5, right? Total sum is 5, okay. All right, so now here also, okay, once we do this again we have two options, right? So here if I draw it like this, okay, here and here we have two options, right? So here let me just again copy this and copy this here, okay. So now in both the cases, now my eye is going to move to the next position, right? So here my eye is going to reach to this position, and here my eye is going to reach to this position, okay. So here my eye is at index 1, okay. Here my eye was at index 0, and here my eye was at index 2, right? Now here my sum, okay, see my sum. So in my sum if I add this previous value, okay, so what I will get? I will get 2, okay. So sum is equal to 2 here, right? Now if I subtract this value, right, so here sum was 1, okay. So from 1 if I subtract 1, I will get my sum as 0, okay, right? So this is how our recursion works, right? Now again if you see, again we have two options, okay. So uh, I'm just covering the left part right now, okay. So here and here we have two options, right? uh, Use plus symbol for this I or minus symbol for this I index value, right? So here let me just copy this, okay, here, and let me just copy this here, okay. And let me just move my page like this, okay. So now here in both the cases my eye is going to move to the index 3, right? So my eye is at here at this index, and here also my eye is at index 3, okay. So 3 index, okay. And now if I use plus symbol for this one, so my sum is going to become 3, okay. And if I use minus symbol for this one, okay, minus symbol for this one, then my sum is going to remain, it is going to become it was 2 until here, okay. And if I use 1, so here my sum is going to become 1, okay. 1 plus 1 minus 1, okay, if I use minus 1 for this one. All right, so here my I is at index 3, okay. Now again we have two options, okay. Tree is going to become a lot of large, right? Okay, so here again let me just copy this here, this one, and here this one, okay. So now let me just move this page to here, okay. Now here if you see my I is going to be at index number 4, okay. So here let me just move this I to index 4, okay, here and here. All right, and here if I'm going to use plus symbol for this one, so my sum is going to become 4. And here if I'm going to use minus symbol for this one, my sum is going to become 2, okay, right? These two are the options that I have. All right, now again come down and solve this part, okay. So now here let me just again copy paste this one here, let me keep it here, and this one let me keep it here, okay. And now my I is going to be at index 5, okay. And here let me do one thing, remove this I from here, and from here, okay, and my I is here, okay, at this particular index. So now if you see carefully, okay, first of all, if I calculate the sum here, okay, if I use plus one plus symbol for this one, so my sum is going to become 5, okay, and if I use minus symbol for this one, so my sum is going to remain 3, okay, right? So now if you see carefully, okay, my I is going to out of bound, right? So my I is equal to the length of my nums array, right? So in that case, what we need to do, we need to check one condition. And what condition we need to check? We need to check if our sum is equal to target. So no, here my sum is not equal to my target, okay. So from here I'm going to simply return 0, okay, and here my sum is equal to 3, okay, which is equal to the target, right? So in that case I have to return 1 from here, okay, all right, right. And now, okay, so here in this part, okay, when my I is at index 4, so here this part is going to return me overall sum as 1, okay, overall sum as 1, okay, this complete part, okay, this complete part is going to return me overall sum as 1, okay. So now if you see this part, okay, see this part, so again we have two options here, okay, we have two options. Let me just copy paste it, okay, this is one and this is one, okay. So here if you see here carefully, okay, so now this is nothing but index 5, okay, index 5 only, okay, and my I is going to be at index 5 only here and here. Now here, okay, if I use this as plus, okay, if I use this as plus, then my sum is going to become 3 here, okay, and if I use this as minus, then my sum is going to become 1 only, okay, sum is going to become 1, 2 minus 1, okay, 1, all right. So index is out of bound, right? So here this is equal to my target, okay, and this is not equal to my target, all right. So this part is going to return 1 from here, okay, and this part is going to return 0 from here, okay. So when my I was at 4, okay, when my I was at index 4 and sum was 4, okay, when my I is at index 4, okay, and sum was 4, okay, sum was 4, okay, and here can I write one more thing, sum plus total sum, sum plus total sum is 5, okay, so sum plus total sum is 9, sum plus total sum is 9, okay, when this was the case, okay. So here I can simply say that when my I was at index 4 and total sum plus sum was 9, okay, in that case my output was just 1, okay, this is one thing. Here what I can say, when my I was at index 4, okay, and sum was 2, okay, and total sum plus sum is equal to 7, okay, so in that case my output is going to be 1 only, okay. This is what I can say here for this complete part. And now for this part, what I can say, okay, for this part, so for this part I can say that when my I was at index 3, okay, I is at index 3 and my sum was 3, sum was 3, okay, and my total sum was 3 plus 5, okay, sum plus total sum is 8, sum plus total sum is 8. So in that case what we are returning, we are returning 1 from here and 1 from here, okay, right. So what we are returning our output, we are returning our output as 2, okay, when my I was at index 3, sum was 3, okay, and sum plus total sum was 8, okay. So 3 comma 8, okay. So here what we are returning, we are returning nothing but output is 2, okay, 2 from here, this part, okay. So here let me do one thing, this is 2 now. So here let me just, this is a 2 what we are returning from here, okay. And from this part here we are just storing 1, okay, like this. And here also we are returning 1 only, okay, this is 1, okay. And from here we are returning a 1, okay, from this part, okay. And from here we are returning 1, this part, okay. So this is nothing but my recursion tree, okay. This is how we need to draw this, okay, this completed recursion tree. Then we have to solve this part, okay. So again here we have two options, okay. My I is at index 3 right now, okay. So here if I draw this, okay, so we need little bit more space, I think, here, okay. All right, we are here, okay. So here I'm just going to stretch it something like this, and here something like this, okay. So if I just copy this here and copy this here, okay, all right. And here my I is going to move to the which index, 4 index, right? Here it was as 3, so now my I is at 4 index, okay, 4 index, okay. So if I treated this I as plus, okay, positive, then my sum is going to become 2, okay. Then my sum is going to become 2, okay. And now if I treated this I as negative, okay, minus, then here my sum is going to become 0, okay. So here if you see carefully, sum is 2, okay, sum is 2, right. And here can I do one thing? So my I is at index 4, okay, my I is at index 4, okay. Sum is at index, sum is equal to 2, okay. And here if I see that my sum plus total sum is 7, okay, all right, okay. I is at 4, sum is equal to 2, and sum plus total sum is 7, okay. Now if I move here, okay, in this part, see this part, sum is 2 here, okay, okay, sum is 2, index is 4, okay, good, index is 4 matching, index 4 matching, sum is 2, sum is 2 matching, okay. And sum plus total sum is 7, okay. So everything is matching now, everything is matching, okay. So this part we are returning 1 from this part, okay. We are returning what, we are returning just 1 from this part, okay. So this part is going to return me 1, okay. So now we are going to store the result of this part in one memoization table, okay. So here we again, we don't need to check this and this again, we already know the result of this part, okay. That is why I have explained this, okay, this, right. So okay. So here sum is 4, sum plus total sum is 7, okay, and this, okay. So here this part is going to return me 1, okay. So here this part is going to return me 1 from here, okay. So let me just do this, okay, 1 from here. And now if I move to this part, okay, so here let's move further, okay, here. So here again copy this and paste this here, okay. So here in both the cases my I is going to reach out of bound, and here I out of bound. Here if I use it as positive, so I will get sum as 1. Here if I use it as negative, then my sum is going to remain -1, okay. Sum is going to remain as -1, okay. So now I'm getting sum as -2, okay. So here if I can say that when my I is at 5 index, sum is equal to -1, but sum is -1, but sum plus total sum is -1 plus 5, 4, right. So because in array we have just positive indexes, right? So that is why in memoization table I am going to store index and the value of sum plus total sum. Okay, so that everything remain positive. All right, so here 1 1 1 1 1. Okay, so if I use -1 for all, okay, then my result is going to be -5. If I use plus symbol for all, then my result is going to be 5 only. Okay, so we have -4, we can get -3, okay, 0, okay, or something like this. Okay, all these values we can get. So in my memoirs table, okay, so instead of negative values, okay, we have this range na, -5 to 5. So I am saying just add total sum here. Okay, so total sum is 5 now. So if -5 plus 5, I will get 0. 5 plus 5, I will get 10. Okay, so in this range I am going to store. Okay, so that all the indexes remain positive only. Okay, so here in this side I have added +5. Okay, in this also I have added +5. Okay, I will get this. Okay, so this is what we need to do. Okay, so this is what we are going to write in the code. Okay, so I will explain that in code, but this is the reason for that. Okay, so from here I'm returning 0, and from here also I'm returning 0. Okay, so this complete part is going to return me 0. All right. Okay, so now we have solved this part. Okay, so here if I want to write 8, so I can say that when my I is at index 3, okay, when my I is at index 3 and my sum is 1, okay, and my sum plus total sum is 6. Okay, so in that case I have to return uh, total output as 1. Okay, 1 only. 1 1 1. Okay, because 1 is returning from here now, from this part I am returning 1. Okay, and from this part I'm returning 0. So overall I am returning 1 here. Okay, so here when index 3, sum is 3, okay, and total sum was 8, or total sum plus total sum was 8. Okay, then the output is 2 here. Okay, and here output is 1. Okay, from this side. Okay, so here I can say simply one thing: when my I is at index number 2, okay, my sum is equal to 2. All right, and my total sum is 7. 5 plus 2, 7. Okay, sum plus total sum is 7. All right, so 2 comma 7, or I can say, okay, this and this. Okay, so in that case, okay, so from here what I'm returning, I'm returning 2. Okay, from this side I'm returning 2, and from this side I'm returning 1. Okay, so 2 plus 1, so here 3. Okay, so here in that case my output is going to be 3. 3. Okay, all right, this is done. Okay, so this part is going to return me 3. Okay, now we move here. Okay, so here we have again two options, right? So here one is this and one is this. Okay, so here let me just move the page to this position. Okay, and here, okay, let me do one thing. Let me just erase it. Okay, let me just move it here somewhere and move it here somewhere. Okay, paste this one here and paste this one here. Okay, so now my I is going to move to the index 3. Okay, so here index 3, my I is moving to index 3. Okay, my I is here, my I is here, and if I use this as positive, then my sum is going to become 1, and here if I use this as negative, okay, then my sum is going to become -1. Okay, sum is going to become -1. Okay, so now if you see carefully here, my I is at index 4. Okay, I is at index 3. I is at index 3, and sum plus total sum is 6, right? 5 plus 1. Okay, so for this part we already know the answer here. Answer is 1. Okay, sum plus total sum is 1 here, 6 here, right? sum is 1, okay, and index is 3. Okay, so we already know the answer for this part. So from here I'm just simply going to return 1. Okay, I don't need to solve this part completely. Okay, now see this part. Okay, so now here let me just do one thing. Let me move this space somewhere here. Okay, so now my I is at index 3. Okay, my sum plus total sum. Okay, this is nothing but minus 1 now, right? This is minus 1, I think. All right, 0 minus 1. Okay, if I use this minus 1. Okay, so my sum is minus 1, sum is minus 1, and total sum is 4. Total sum is 4. Sum plus total sum, sorry, sum plus total sum is 4. Okay, so have I stored this result? 3 and 4, 3 and 4, 3 and 4, 3 and 4, 3 and 4 I haven't stored yet, right? So here now we have to solve this part. Okay, so this is minus 1. Okay, this is minus 1. All right, so now again we have two options here. Okay, again we have two options, so let me just copy this here. Okay, and let me just copy this here. Okay, and now I'm going to move I to the next part. Okay, so my I is going to reach to this index, and here also my I is going to reach to this index. All right. Okay, so now here see carefully, if I use this as positive, so my sum is going to become 0. Okay, and here if I use this I as negative, okay, this I as negative, then my sum minus 1 minus 1, it is going to become minus 2. Okay, sum is equal to minus 2. Sum is becoming minus 2 right now. Okay, so here here I already know the answer of this part, right? I already know the answer of this part, because here see, here my I was at this index. Okay, I was at this index, sum was 0. Okay, sum plus total sum is also 5. Okay, so in both the cases, so from here I'm returning what? 0 0. Okay, so I know this part 0, so it is going to return me 0 only. This part is going to return 0 only. Okay, this part is going to return 0 only. Okay, and what about this part? So here minus 2. Okay, here we have minus 2 now, right? And we haven't stored this result in the past. Okay, so here I have two options. Okay, so again let me just copy this here. Let me move this page to this position. Okay, and let me just paste it here. All right, so here my I is going to reach out of bound, out of bound, out of bound. Here my I reaches here, I reaches here. Okay, if minus 2 minus 2, and here if I use it positive, so it is going to become minus 1, and here if I use it negative, so here it's going to become minus 3. So both are going to return me 0, because my target is 3 now. It is going to return 0, so it is also going to return 0 here, right? And overall it is also going to return 0 here, this side. Okay, and now if I move my page here, okay, clear now, this is clear now, both are returning 0 0 here. Okay, target is 3 now, so it is also going to return 0. And here if I move here, so this part is going to return 1, this part is going to return 0. Okay, so overall this part is going to return me what? This part is going to return me 1. Okay, so when my I is at 2, I index is 2, sum is 0, total sum is total sum plus sum is 5. Okay, then in that case at this part I am returning 1. Okay, so I am returning 1 here, 1 here. Okay, and if I move this here, so from here I am returning 1, and from here I am returning 3. Okay, 3 here. Okay, so overall at this part I am returning what? 4. So I am returning 4 at which index? At index 1, sum 1, and sum plus total sum is 6. Okay, so at this part, okay, where my index is 1, sum plus total sum is 6, I am returning 4. Okay, I am returning 4 here, 4. Okay, now see this part, now see this part. Oh, sorry. Okay, now see this part. Okay, so let me move my page to this position. Okay, so now here I have two options. So here this side, okay, one option, and this side one option. Okay, if I just copy paste this here and this here, Okay, so my I is going to move to the index 2, both the positions. Okay, so I is here, let me write I here and I here. Okay, at this position. Okay, so now sum is -1. Okay, so in this -1, if I treat this as positive, okay, so my sum is going to become 0. Sum is going to become 0. Okay, and if I treat this as negative, okay, this is negative, then my sum is going to become -2. Okay, sum is going to become -2. Sum is going to become -2. Okay, -1 and -2. Okay, so this part we already know the result. Okay, see here, when my I is at 2, sum is 0. Okay, sum plus total sum is 5. So we already know result, so we are returning 1 from here. Okay, so from this part I am going to return 1. Okay, now this part we have completely solved. Okay, that is the use of memoization. Okay, so we already know the result of this one. Okay, all right, now let's move to the this part. Okay, so here this one, so here again, if you see, so we have two options. Okay, one option here and one option here, and here if I just copy it, copy this here and copy this here. Okay, my I is going to move to the next position. Okay, I here, somewhere here and somewhere here. Okay, and if I remove it, remove this, so here -2, and if I use this as plus, so it is going to become -1. Okay, -2 plus 1 is -1, and here if I use it negative only, so I will get -3. Okay, so for this part I already know the result, 0. Okay, this is turning 0. Okay, so here I is equal to 3, sum is -1. Okay, and sum plus total sum is 4. Okay, so this part is going to return me 0 only, and this part -3. Okay, so now we have to solve this. Okay, so here if I move further, okay, so here I have again two options. Okay, this and this. Okay, so here if I use this, my I is going to move to the next position. Okay, I is going to move to the next position. I move here and I move here. So if I use this as positive, so my sum is going to become -2, and here my sum is going to become -4 if I use it negative. So -2, we have already solved this, so this part is also going to return 0, and this part, okay, by default you guys are already aware, okay, but it is going to return. Okay, so -4, again we have two options. Okay, so if I use a positive symbol, so here I will get this part. Okay, -3 somewhere, so I'm going to return 0 from here, and -5, it's also not equal to target, so it is going to return 0. Okay, so overall all this complete part is going to return me 0. Okay, so if I move here, okay, main portion, okay, so here this part is going to return 0. So 1 plus 0, so 1 only. So from this part I'm going to return 1. Okay, and 4 plus 1, so here it is going to be 5 here. Okay, so 5 is going to be my output. Okay, so this is how my complete recursion is going to work. Okay, so I don't think that anyone will explain this recursion whole tree. Okay, so in this video I have explained the complete recursion, the complete process of recursion for this particular example. Okay, so now let's write the recursion plus memoization code. Okay, so here use total sum. Okay, and we will just calculate the total sum value, okay, that we have. So here uh, inside this, just update my total sum as arrays dot stream. Okay, and here nums dot sum. Okay, and now calculate the memoization array. Okay, int memo, so new int, and here I have explained, okay, the size. So here we have to write nums dot length. Okay, nums dot length. Okay, and here this is nothing but the indexing part. Okay, whatever index. Okay, and here we have to write the total sum. Okay, so here I will pass 2 into total sum, okay, plus 1. Okay, so I have already explained, right, this part. Okay, why we are using 2 into total sum, so that we make it positive. Okay, if I get -5, so I will make it as a positive 5. Okay, so that is the only reason. Okay, so for -5 we are making it positive 5. Okay, so all the values are moving now, so -5 to 5, but it is good enough to write it like this, 0 to 10. So we are making it everything as positive. So we have this size 2 into total sum plus 1. Okay, 2 into total sum plus 10. Okay, so that's the reason. All right, now after this, okay, for now just iterate over all the rows in my memoization array. Okay, and here inside this just fill, okay, arrays dot fill a row. Okay, all the rows we are going to fill with integer dot min underscore value. Okay, and now after this, okay, once this is done, okay, we have filled all the values with the minimum. Okay, and here from here I'm just going to return this calculate ways. Okay, and here we are passing what nums. Okay, we are going to pass index, starting index. Okay, we are going to pass the sum. Okay, and we are going to pass the target that we have, and we have to pass memo. Okay, right, and yeah, that's it. Okay, so now let's write the code for this calculator base. Okay, so here only we are going to get the result, right, as explained in the diagram. So now here let's write the code for calculate ways. So private int calculate ways. Okay, and here we are just going to pass nums, we are going to pass index, we are going to pass sum, we are going to pass target, and we are going to pass memoization. Okay, now here we have to write if index is equal to nums dot length. Okay, okay, so if this is the case, then we have what we have to check, we have to check, okay, if my target is equal to sum. Okay, so this is what we are checking, right, target is equal to sum. So if it is matching, then what we are doing, we are returning 1. Okay, otherwise we are returning 0. Okay, so I have already explained all these things, right? Now here let's use a memoization as well. So if we know the value of this memo of index, and here the second value we are passing of is of sum plus total sum, right, sum plus total sum. Okay, if we know this value. Okay, so if it is not equal to integer dot mean value, so what does that mean? That mean that we have already updated this value in the past. Okay, okay, so if this is not equal to this one, so in that case we have to simply return what, we have to simply return this value. Okay, mem of index and sum plus total sum. Okay, now same add and subtract, we are doing two things, right, add and subtract. Okay, so here what we have to do, we have to just paste it. Okay, and here nums and index. Okay, this is same thing as previous code. So index plus 1. Okay, and here sum is going to be sum plus nums of index. So what is the extra thing that we are doing? We are just passing memoization extra thing. Okay, and here same thing now, index plus 1 and sum minus of nums of index. Okay, so minus of nums of index, that's it. Okay, and okay, so this is one thing, and here once this is done, then after this what we have to do, we have to write here return. Okay, so from here what we are going to return, we are going to return memo of two things. Okay, index and here sum plus total sum. Okay, and here is equal to add plus subtract. Okay, so from both the sides we are adding the value now, from left side, from right side, when we are using plus symbol, when we are using minus symbol. So that's what we need to store here. Okay, so now let's run it, okay, and see if there are any code issues. We'll try to fix that. So all the test cases have been accepted. Okay, now let's submit it. Now see where we are. So see, now we are here. Okay, previously we were here without Memoization. Okay, now we are here. Okay, so I hope that you guys are clear with this approach as well. Okay, recursion and Memoization. And if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. We'll see you guys in the next video. Thank you. Bye bye.